This is my book review of A Brief History of Time by Stephen Hawking. So, this book, I want to say overall, it's a very good read, pretty clear, but you definitely want to have a little bit of background in physics, like at least taking physics in high school, or a little bit of like YouTube kind of scrolling on physics to get a good understanding. It has a lot of really good ideas. It is a little bit outdated. I think this was published before the 2000s, but a lot of the ideas and the way he describes them are actually very clear. There's some good diagrams I really like. So I'll go into kind of my notes, but I think that, I like how he presents stuff. I like how he writes it very clearly. I haven't read other physicists yet. One of the top people on my list is Richard Feynman, Six Easy Pieces or something like that. So I would like to read that first before I can say that like he's considered that Stephen Hawking is considered a clean and very clear, easy to read physicist. But he has a lot of other books too that I actually now, after having read this, am looking more into because he does a good job exploring the nuances. He even acknowledges that he's wrong in print, which I think is really, really valuable. He said he had some other theory before that was wrong, and he admits that. So I'm going to go through my notes, share what I learned, and yeah. Okay, so it first starts about making the case for explaining how we got to the theories of physics that define the way we see our world today. He acknowledges the complexities and societal resistance to using science to explain the origins and creation of our world. So he goes through kind of a little bit of a mini history lesson to see, okay, where do these theories come from? Why do we understand it like we do? So he has some really good diagrams in the book, right? This idea of space-time, which is pretty abstract, but it's very useful because it combines physical space and progression through time in like kind of a graph. And he has really good, clear explanations that I don't think are overly complicated. So the idea of space-time, it's kind of like having, a fourth dimension, if you will. But it's showing how, like, he also talks about the arrow of time and the arrow of our psychological time, and how, like, the arrow of time only moves forward, and that's, like, proven by a lot of different things, like the entropy idea that things only get more disordered, the way that we don't think of the future first, we think of the past, right? And our brains are not wired to, like, think in the opposite direction. And, yeah. Okay, another thing he talks about is because of the delay in light reaching us, when we look at the stars, we're looking at the past. Just like how if the sun turned off, we wouldn't know for 8 minutes. So I thought that was pretty interesting because it means that we're like watching a rerun of the universe when we look at the stars. So even though, you think like, oh my gosh, all these people with this like super expensive telescope going into space, looking at the stars, and then all of a sudden it's like, well, actually those are all like, many, many years old. All the information that you get from seeing that is much older than, so it's not necessarily as of right now super accurate. Okay, in space, light doesn't travel in straight lines. It is affected by things with large masses like the sun, which cause it to curve and distort. That was the other thing I was thinking about. I was like, okay, well, if you're looking at these telescopes and all these like stars, right? How do we know those lines of light coming at us haven't been distorted? I mean, they probably have. So it's kind of like you're looking at a map, but everything's probably been shifted a lot, and it could be shifted differently based off of where the gravitational forces are higher or lower because of larger bodies and things like that. So kind of interesting. Another cool thing I learned was that time runs slower the closer you are to a very large body of mass like the Earth. So the closer down you are versus the higher up you are away from it, time would run slower if you're closer down to this core of the Earth. Yeah, so the main part of this book that gets pretty confusing is the quantum physics part, as well as the quantum physics quantum gravity uncertainty part. So I think that like I was able to kind of understand like most of it because I've already taken like physics, and they did have a quantum side there, but the quantum part's not the most difficult part. It's just like it gets into the weeds a bit. And so you really have to like stick with it, maybe take a break, come back. Yeah. Okay, and then he talks about the origins of the universe and that idea, which also does get a little complicated too. But he talks extensively about the Big Bang in relatively simple terms, and he allows you to think about the scientific approach to the creation of the universe and questions that endlessly arise from it. how and why are the kinds of questions that become very hard to wrap your head around if you imagine the universe continues on and on and on. Because it's like he's talking about how you can break down atoms into smaller pieces and eventually get to quarks, or you get to like string theory and stuff like that. And it's like, well, what's before that? What's the smaller piece of that? And you can just keep going on and on and on forever, right? And like then you get to a point where it's like, can I even test this anymore? Because he was talking about how like you can have accelerators that smash particles together at really high speeds to try to recreate these environments, but sometimes you just simply don't have enough energy, right? You need like the same amount of energy of the sun to kind of observe certain phenomena occurring, and that just puts a really hard cap on what you can actually do and see. Yeah, his theory of kind of how, the other thing is he's really well known for black holes. So that's the kind of thing I searched up, right? So it's interesting how black holes are actually relevant to how the universe is kind of created, because the idea is that black holes, they can represent like a singularity, which is the idea of the Big Bang, right? That everything came from this one moment in time. But he definitely questions that as like, does there have to be a singularity? And I myself am not entirely sure about like what a singularity means, because it's still pretty confusing in the book, but I'm sure I'll get it over time. Okay. But yeah, so his theory of the creation of the world is that there's no real creation point, right, which would be a singularity, but that there is an expanding and contracting of the universe that has no singularity, so there are no definite points. And this is an interesting part, to which there could have been an actor like God to begin the world, even if he were to create a set of laws which govern the universe. So the point is like, it's not a start point and end point kind of thing. Because if there was a start point, then you're like, oh, there could have been something before that start point that initiated the start point, right? But he's saying if things just exist and things only continue in a sense like an infinite loop where there is no beginning, and it's just kind of like just like the earth, right? He says like it's perfectly smooth, right? So that idea where there's this smoothness where things can expand or contract, but there is no like definite start point, because if you say the Big Bang happened, well, then he also says there's a big contraction moment that would happen at the end. And technically, when you have the two sides of the beginning and end, you could probably put those into a circle and then say that, oh, it just goes around like this. And then technically there is no beginning or end, because it's just kind of constant. So I'm sure there's a lot more nuances there that I'm not really, adequately explaining, but I think that's kind of what I got from that. And he had a very interesting point where he's saying that the only reason we're allowed to question the universe is because we exist in a period of the universe's lifespan where the theme is that everything becomes more disordered. And that allows us to kind of exist because we eat food, we release heat, that all increases increases entropy and disorder of the universe. Right? If the universe was already super disordered, kind of like a black hole, or the opposite of the Big Bang, right, which is the big contraction, then we would not be around to question the reverse process of the universe, because we would be dead and couldn't observe it, right? So yeah, that's the idea. If everything was very disordered, right, then that means that it's just elements all over the place, right? There's no structure, and that there's probably just so much heat, energy, just raw energy, elements, all gas, really like all over the place, right? So that would not be conducive to forming life, and then that couldn't form us, which then could question things. And so that gets into the realm of, it gets pretty difficult of like, okay, well then how can we postulate and think about stuff that we're never going to be able to observe? And I think that's where it's difficult, right? Because then you have to think, he talks about this too, it's like you have an idea and you have to figure out how you can test that idea, because you're getting to a point where it's so kind of far off. And I mean, like now, I'm pretty sure it'd be cool if he was still alive, because then he could do an update version of like all the stuff in 2026 now that like we know, and that's something I am pretty curious about. But yeah, I think this book overall is very good. Intro to, if somebody's interested in kind of like physics. I definitely think that physics is good, at least at some level, and that like you can observe stuff and then confirm things, so you're not just endlessly thinking, right? And I think that it's good to be a generalist in this time of like, it's good to learn a little bit about different fields, so that you're more well-rounded and you can bring in these different aspects of these different fields in combination, rather just being super, into one field. So it's great that he was super into physics, so I can read his book, but I'm saying as an individual, I don't agree with the idea that you put everything in one field and you make yourself a dud in all the other subjects or kind of areas around it. If you have any questions, put them below. Otherwise, subscribe for more, and I'll see you in the next video.